Okay, we back? Let's see if we're back. Maybe? Nope, we're back. Okay. I think. I swear this has never happened before. Hopefully it won't continue to happen. Alright. So here we're going to have that ID. When we go to load the vertex shader, and that will be good because we'll be able to tack it on right here. Okay. So let's go ahead and add that. It'll be like resource ID. And then shader storage, ID equals ID. Good. So that will put all of the, so that'll make a big list of all vertex shaders, just a flat list, not even sorted or anything, which may not be the best. We'll make sure to improve on that before we go too much further. Let's copy this down here. And everything down here that says vertex should say fragment. Fragment. We need some capital F's. All right. Good. Good. Fragment shader, vertex shaders. So you need to make a new one. Oh, I need to do this. Resource ID. ID. All right. Here's my list of vertex shaders. Here's my list of fragment shaders. All right. So at least now we're storing the data somewhere. And so now, like, when it's time to free it, we'll have an actual thing that we can free. So that's an improvement. No type name fragment shader ID. What? Did I not? Fragment shader ID, it's right here. Why would you say that? Oh, it's right. That's right. It's because I'm forward declaring this stuff. So let's fragment shader ID. Okay. You know what? I'm not sure I like this. Maybe I should have like a The fact that I'm storing all of the rendering handles in the header, like maybe I should. Ugh, I don't like this idea, but maybe I should make a new like allocation that's only accessible from the CPP, and then I don't have to do all these forward declares. I don't really like the idea of that, but like, yeah. So here, I think I'll do it, and I think I know how to do it. So what I'm going to forward declare, I'm going to improve the structure a little bit. I'm going to say, struct resource data, something like that. Resource data is a stupid name, but okay. Then take all this stuff out, and then let's just make a pointer to the resource data. Okay. Then in the initialize function, data equals, and then initialize it. Here I can actually declare the struct resource data. There's all that junk. This guy can be public because he's only going to be accessible inside the class anyway. So it should be fine. So now resource data, I can allocate right here, resource data. And I forget the parameters for Valak. Buffer size, buffer size. How big? Oh yeah, of course. Size of. Wait, I have an overload that will do this for me. This guy. So I don't even need to write that. I can just say singleton. I'm pretty sure I can use a singleton allocator here because there's only going to be one resource loader ever in my program. So that should be all right. And then vfree data when I'm done. And yeah, that should work fine. All right. So now when I dereference vertex shaders, I have to say mdata pointer, and same thing with fragment shaders, mdata pointer. So now we've gotten rid of those. Now we can get rid of these forward declares and use just VTB render. Should be fine. Should work fine. Should work good. Oh, well, I guess we still have to do a forward declare for instance. That's fine. That's no big deal. Assigning from incompatible type void. What is going on? Oh, wait. I have to do this. Resource data. No matching member. Oh, I didn't add. I have to add some words right here. Resource ID. Good. Unknown type vertex shader. That's because it's resource data : fragment shader. Okay, now we're back to the good. Now we're back to the linker errors. So we hide the resource ID inside this fragment shader. So now when it comes time to free a resource, to delete a resource, I can just walk this entire array, and find all of the resource IDs that match the resource ID that I want to delete, and call into my renderer and say, delete this shader ID, delete this shader ID, delete that shader ID. Just delete, delete, delete. Then I'll have deleted them all, and then we'll all be happy, I think. So then the final piece here, I think, is to actually do this reference counting. This reference counting right here. And in fact, I have a thing that will help me do that. A really gross class called Cotter. Cotter. Okay. So the idea with Cotter is that you implement your class and you implement this allocate, copy, swap, and free, which are the four easiest like things to implement. And then you use this Cotter class to, like, it does RAII for you, but RAII is actually tough to get right. It's actually tough to get right because, like, orders of things matter, and, like, you can forget to define one of these operators and all this junk and all. Okay, you don't have to want to worry about that. So you just implement these four functions, and then you use this class, and it'll always work. Is the idea. So we're going to implement reference counting using this, I hope. So let's try that now. Let's close a few things to clear up some space, to clear up some sanity in my head. Get rid of this, get rid of that. So there are two parts of it. One is the actual Cotter. Okay. I think I can do it this way. Resource counter. And then in here, this is where I put this guy actually. And maybe some methods. So I have to put these 4 methods in here. This is my implementation. Can get rid of these comments. Okay. Actually, this looks like it's super useful, and I should just put it here. Yeah. That's a good idea. Like, I'm pretty sure I'll be able to use a resource counter at a later time. So I should just include it in... Because I probably don't usually want to do actual resource management here. Almost all the time. Because like I said before, I don't actually like it when you do a... When you do a delete here. When it's an actual free. Because of the cascading problem. Not my favorite. So, if I can just make it easy to make a resource counter out of the, oh, by the way, COTR stands for constructor allocate, destructor release or something like that. Yeah. In fact, I think that's it exactly. So if I can just make a resource counter out of this, then it'll be really easy to build resource counters out of COTR, and then hopefully people do that instead of writing other stuff. Maybe I should just call it resource counter. Where else do I use this thing? Yeah. This is old code I don't use anymore. So that, yeah, this is the only place I use this. I should do that. I should just call it resource counter. That's what I'm gonna do. That's what I'm gonna do. Save in a new file. Reference counter .h. Okay. So it's no longer a templated class, see? Simpler. Reference counter. Our object is references. It starts at 0. It's private information. Allocate. Actually, this is implicit. I don't even need this. Because, you know, there's an implicit constructor that assigns it to 0, so that's fine. Copy references equals C dot references. Easy. Free is easy. References minus. Wait a minute. I can't do it like this. Yes, this is C++. I can't do it like this. Because I have to have some other place in memory. Like, I have to have one actual integer. No, this is C++, yeah. I have to have one actual integer that does... It's just like... Right now, I have everything defined in the... this is a header file. But right now, I have everything defined in the header file, so it looks like there's not a header file. But it is a header file. So if I want a class that does reference counting and undoing all of this junk, then I have to have, like, if I have a bunch of different reference counted, like, pointers to reference counted objects, if I have a bunch of different pointers to a reference counted object, then I have to have like a single oh my god, a single place that contains the integer that represents the number of reference count. Like I can't have one in each of the handles. But no, this is fine because having done C++ and you had a nightmare with JavaScript. JavaScript is indeed a nightmare. Well, if you have any questions about C++, I'm happy to answer them. We're in the deep end here, so this is probably pretty complicated. But don't let that deter you. It's, yeah, like you can ask any questions about particular things if you want. I'm happy to answer them. I did this before. I'm just gonna, yeah, see, remove reference. Yeah, that's what I need. So I'm gonna map out what I need here. Okay, so I need a handle, and the handle's job is to like increment and decrement ref count. Thank you. And I need the object that you're actually ref counting. And this should contain the ref count. I appreciate you talking through it. I speak enough programmer, I understand your logic. Good. So each handle, when the handle gets created, it will go into the object that it's referencing and increase the ref count there. And then when it gets destroyed, it will go back into the object and delete the ref count there. So so this needs to be like m references plus plus. But we need like this. We need struct ref counted. It's kind of gross actually. So let's do it this way. Let's make it a template class. As much as I'm not really a big fan of templates, I'd rather make it a template class than make so the object has to contain the ref count. So I have options, right? I can make a base class, and any object that I want to be ref counted has to extend that base class. But I don't know. I don't like that. Well, as long as there are no virtual functions, it should be fine. Still pretty gross, though. The other way is to do kind of duck typing and have a template, and you give the reference counter the object that you're ref counting as a template, and then you just make sure that you define the interface that the that the ref counter is, that the handle is looking for. Then you run into problems if you're trying to create a new object. You know, I'll just do this stupid. I'll just do this. Yeah. Should be fine. Because I can do this. Friend class reference counter. Not doing shared pointer because when you delete the last shared pointer, the object automatically gets deleted. So it's not like I want ref counting, but I don't want the shared pointer behavior where it deletes it when, like, the object isn't owned by the shared pointer or whoever holds the shared pointer. It's owned by my resources class. This guy owns it, okay? This guy decides when to delete it. The ref counter just lets the resources class know how many people are interested in this thing, right? And if I want to delete it even though people are still interested in it, I want to be able to do that. You can't do that with shared pointer. And if I want to not delete it, even though no one's interested in it, I still want to be able to do that. And you don't get that with shared pointer. So, again, because I mentioned it before, if you, like, this is a problem that a lot of the C++ standard library has. If you delete an object, then you get a cascade of deletions. And you get unbounded time to delete things. And it's a super big problem if you have like really large graphs. And each node in your graph has a shared pointer to an edge, and each edge has shared pointer to the other node, and then like you delete one edge and it had a huge graph hanging off of it, and you just get cascade of deletions. Delete, 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 delete. And that takes 2 seconds to make one tiny little edge deletion, probably in a place that you didn't want to do it. Like you just wanted to, the user wanted to press the delete button and then delete do a small operation, and then like if there's a disconnected graph, you can free all that in the background, right? You don't have to do it right now. So that's what I'm doing. So this should be okay. So reference counter, we need a pointer to the ref counted object. We need to hold on to that pointer, I think. Probably. Let's make a C++ file for this. We're gonna do it the right way here. Reference counter and now we're gonna have to add it to the CMake junk. Okay. Include reference counter.h. There is a weak pointer, which does not help with what I just said. Because like, so the weak pointer, like, okay, so like I said, you want to be able to not delete when there are 0 references to it, and the weak pointer doesn't help you with that. Yeah. The weak pointer might help you with you want to be able to delete even if there are references to it, but you still want to choose when to delete. And the weak pointer, with the weak pointer, like if there are only weak pointers to it, it will die. Right? Like I don't want it to die just because there are no strong pointers to it. I'm trying to like decouple the reference counterness from the strong weak pointerness. Like, yeah, okay, well, anyway. I hope you get the idea there. So object equals object. So when we make a new reference counter, it's gonna get this object. You better not pass me a null object. Okay. And then it will, because I'm a new reference, because I'm a new counter, I'm a new reference to this object, I'm going to increase the references. Okay, so like, this thing is the equivalent of a strong pointer, but I'm not even going to make a weak pointer. I'm not even going to bother with that, because the resources cares sometimes, but doesn't care other times when something is referring to it. It wants to be able to delete whenever it wants to delete, and sometimes that it matters that things are pointing to it, sometimes not. And I don't know, whatever. Okay. So if I'm copying another reference counter, then that increases references. Increases the number of references. So this is a copy. This is a what's the word? Copy assignment constructor, copy assignment operator. So in that case, there's an existing object that I'm referring to. Like, okay, I'm a reference counter object, but somebody called copy or assignment operator on me, and he's going to assign a new reference counter to me. So I have to first delete the old thing that I was pointing to. Let me actually make this a valid C++ file here. I painted myself into a corner. Delete all this junk. Okay. So if I was previously pointing to an object, reference, reduce the number of reference. So whatever was in this reference counter before is no longer going to be pointed to. So then we say we take on the value of the new object, and then so the new object now has one additional reference to it, so we add that guy in there. Now this is the move constructor. So same thing. If we were previously pointing to an object, we gotta remove a reference to it. And then we got to... Oh, this is a swap. So that's different. I'm not even gonna have to free, probably. I can just swap. I think I can just do this. In which case, this might actually be wrong. Okay. And then if when I get destroyed, if I'm pointing to an object at that point, then I reduce references. I think that should do it. Probably need a protection here, because the thing that I get copied from might not actually have a valid pointer. By the same token, I need a protection here. All right. And that should do it. I don't need this. Oh, give me a break. What is going on? Reference counter defined as a struct here, but yeah. We'll make it a class. I don't even care. I don't even care. Oh yeah. So we can now get rid of all these implementations because I made a CPP file. Okay. I don't really like that I've defined, in fact, I'm not using Cotter anymore, so I'm just gonna delete that file. I don't like it. It's gross. Okay, I don't like that I've defined a copy constructor and a copy assignment operator and a move constructor, but not a move assignment operator. So I'm gonna make a move assignment operator. Shouldn't be too hard. What the hell? Let's make that move assignment operator. All right. It's gonna look pretty much identical to the move constructor, except it will return this at the end. We need a default constructor. Undefined reference to assert. I think we can just do this. All right. So coming back to here, our resource handle is just a reference counter. Yeah. What's that? What operators to implement? Gotta follow that rule of 5. Yep, it's the rule of 5. So, Catshoke is the question like why we're implementing all of these operators and what they mean and all this stuff, rule of 5 stuff. I don't know why. Like, I deleted that Cotter file, but like I don't know why I didn't follow the rule of 5 there. I apparently followed it here, not there, because I'm a bad programmer. It's true, man. I'm a bad programmer. Yeah, so the resource handle is a reference counter to a resource. That means we need an actual resource to like refer to, which is fine actually. I think we have can we created some resources over here, didn't we? Where was that stuff? These guys can be the actual resources that we're ref counting. I think that should be okay. So that'll look like this. Public reference counted object. Aren't we all indeed? Aren't we all indeed? So these guys are reference counted objects. That means that, oh, this is gross. So maybe I shouldn't be templating on asset type, but I should be templating on this guy. I have a question, but it's off topic, which is fine. Just wanted to listen to my opinion. Do you think screen space reflections are now a better option over environment mapping? Oh, that's an interesting question. I'm hardly a rendering expert, so I don't know if I'm the best person to ask that question. The answer is probably it depends. You know, it depends on what you're trying to go for. Some games lend themselves very well to screen space stuff. Some don't. In that case, you know, you have there are two options, I would say. Like being not a render programmer, like it depends on what you're. So like maybe you have a lot of static geometry and you can afford all of the. You can afford pre-processing to your heart's content, and you don't have a deferred renderer, and so environment maps are great for you in that situation. Or maybe your game's very dynamic and you like dynamic lighting and dynamic environment, dynamic everything, and you have a deferred render and like, you know, and in that case, screen space reflections might be better. I don't know. It depends. It's probably not the answer you wanted to hear, but Oh, no, it's fine. So I don't need a template on this thing. This is fine. Reference counter. Reference counter is not a... Close this. Reference counter is not a template class, no. Good. Okay. So what does this mean? Problem with this is that there's no type safety. Because, like, if I make a resource handle that's tied to a particular, like a fragment shader asset type, I want to make sure that that resource handle can only reference count a vertex shader object. Like, if this T is vertex shader, then the thing that it reference counts should only go to this vertex shader struct. And the way I just wrote that reference counter, I'm not sure I'll get that, which would be no bueno. I can protect against that by making like a special constructor that does that in one place, and then hopefully that's always kept up to date properly. Or I can... What else could I do? Vertex shader. Maybe I could do some other magic. What's your thing if you say you're not a rendering person? I guess I'm what they would call a generalist programmer, meaning I don't have a like a specialty, which doesn't really mean anything because you're only actually doing your specialty like 20% of the time anyway. Like I work with a guy who's AI, and our AI programmer's been doing a lot of AI actually. So our networking programmer has not really been doing any networking for the past 6 months, right? Like our rendering programmers spend a lot of time doing systems work and stuff like that. When they need a rendering person, they go to you, but there's, they can't always fill your bucket with only rendering things just because you're a rendering person. And then sometimes when you're a generalist, you get sucked into doing specialty stuff also. Like there's a guy on our team who just got moved on to the networking team because suddenly network stuff is really important. Our network performance is bad, and like we need 2 network programmers instead of 1. Oh no, we only have 1. Okay, Bob, you're a network programmer now. But a lot of times, like having a specialty can be good. Anyway, that is somewhat of a tangent. I'm a generalist programmer, yeah, which means I like everything and I do everything. I try and learn about everything. So you could also think of a generalist programmer as like someone who does maybe not systems work. Well, yeah, systems work. Or a gameplay programmer. Gameplay programmer, generalist programmer, something like that. That's what I do. That's what I'm good for. Programming and math. You could say math's my specialty, because you could say math degree. The math degree helps. The problem is like right here is where I would have to do that. I don't want just any ref counted object. I want a particular kind of ref counted object. But since I wrote this reference counter, now this thing can refer to any. So I guess I need to make it a templated class, huh? That's what I need to do. Sad. I was hoping I would get away without making a templated class. Oops. Yeah, public. It's fine. It's fine. Oh, but damn it, that means I need to copy all this over here. Templated class. I can't say what I'm working on, sorry. The company I work for, very much doesn't like employees talking about their company. So I prefer just never to say who I work for. That way I can say anything I want. It doesn't quite work like that, but for now, yeah. For now, I don't tell anybody who I'm working on. Do templates affect runtime performance? I read somewhere they can increase compile times a bit. Or is that completely wrong? That's probably arguable. I'm under the impression that they do. I've worked on a lot of projects that use templates a lot, and guess what? Those projects compile very slowly. I'm talking about like 20 minutes to link or something like that. It happens. So the intention of templates is that they increase runtime performance at the cost of compile time performance, right? Because they have the compiler do processing that then the user doesn't have to do, right? But that extra compiler processing is what adds up and increases compile times. Some types of templates, though, are more expensive than others. For example, template. I don't have any empirical knowledge or evidence of this, but I believe it to be true. That if you have a class like this that has two template parameters, and then you do what's called a partial specialization, where you go like this, that's not a default parameter for S. That's like explicitly choosing to leave S as a template, right? You're only going to fill in the value for T, and it's not a class yet. It's still a class template. It's a partial specialization. This isn't the right syntax for it, because I don't use it enough to remember that offhand. But partially specializing the template means you have to make another template that has that thing, that has the T specialized but the S not, and that's a lot of work for the compiler. So I think this sort of thing tends to take a lot of time to do for the compiler, for example. No, it's so I wouldn't call it a corporate nightmare. It's actually a really nice place to work, except for like 2 or 3 really weird things that, whatever. Every place is gonna have at least 5% of things that you don't like about it. Like even if you worked for yourself, even if you're a contractor, that 5% is that you never know if you're gonna have food on your plate tomorrow. You know what I mean? Like, there's no place like, yeah, they were burned before. They're careful. It's a big company, so, leaving out one template class would still compile. Yes, well, not with the syntax that I use. Let's see, partial template specialization. Let's look up the exact syntax. I'm not interested enough to do, there it is, to do like an experiment to see how much that affects compile times, but there you have it. You can retain the template. So you retain the templateness of key, but you instantiate the templateness of the other thing, and so that sort of thing. Again, I don't really know that they're slower, but my impression is that they're slower, and they're used a lot in like Boost. It's actually a really powerful tool. You can do a lot of cool stuff with it, but then your compiler takes 20 minutes or whatever. So now my reference counter.cpp is empty, but I have a little bit more type safety. Like, type safety is another great thing that templates do, yeah. So now my reference counter, it's 8 o'clock. Now my reference counter is a little more type safe because I can specify exactly what kind of reference counter I want. I want a reference counter to this type of object only. But, and it, obviously it has to be one of these things as well. But now the compiler has a little more work to do as well. You know, it has to check that, it has to instantiate this template every time I use a reference counter. I'd rather let it compile for 30 minutes if it gives me a bit of a performance boost. Are you sure? Like, that's sometimes true that you want that performance boost, and sometimes not true, right? Like, no, you're right. Like, when I was a freelancer, I really liked knowing if there were, you know, not knowing that there'd be no food on the plate tomorrow. That wasn't fun. What I liked was working for myself, but there are still things that are not nice about being a freelancer. Paying taxes, for example. Paying taxes is the worst if you're a freelancer. Yeah, so like if it's your, yeah, it depends on what you're working on. It depends on your thing. It depends on what you're doing. If you get too much into template metaprogramming, then yeah, your compile time will slog a lot. How much faster will your program be for it? You know, like iteration time counts as a lot. If it takes 30 minutes for your program to compile, how good of a program are you going to really be able to make? If you have to wait 30 minutes before you see the result of the thing that you're working on. That sounds like a pretty bad process for making a good program to me, right? Like, if it's free template boost for the user, then yeah, do it. But normally you always pay a cost for everything, right? Nothing is free. The templates help you in some ways and hurt you in some ways. You just have to evaluate that trade-off. I don't know, I'm lecturing now, so. Back to reference counting here. So now I can't just say resource handle reference counter. So now I actually have to provide a type name S and give this S right here. So now I can enforce this a little bit better. No I can't. I can't define this here because I need this defined. Ah, crap. I have to be able to write struct vertex shader here, but I wonder if I can do that with a forward declaration. Ugh. See, so this is the other problem. This is the other problem. I am no longer solving my actual problem. Now I'm solving another problem that is similar to my actual problem, but is not. It's a C++ problem, right? Like, now I have to figure out how to make the C++ syntax do what I want it to do. Let's rename this thing vertex shader data to disambiguate it from this asset type right here. Data. Vertex shader data for declaration, and then my actual problem has to do with compiling shaders, but the problem I am currently trying to solve is how to wrangle C++ into doing the thing I want it to do. I don't think I'll be able to use this for declaration because reference counter is a different kind of symbol. What? Oh, yeah. Friend. See? Now I'm like, my problem is how to make C++ do the stupid thing that I want it to do instead of the actual problem, which is compiling shaders asynchronously. Friend template class. Let's look up the syntax for making a friend class that is a template class. Hooray. Am I a programmer yet? Template. See, the template goes in front of the friend. I would not have guessed that. Template. Type name T. I hope that works. Yeah, that does seem to have worked. Reference counter is not a class, namespace, or enumeration. That's not true. It's right there. Reference counter. Reference counter. Reference counter. Reference counter. Note declared here. What? Error. It is not a class. Note. Here it is. Am I missing something? What is it? Duh. Reference counter. Reference counter. Reference counter. Is not a class. Wouldn't I have to pass in a type? Well, no, because I have two constructors. Here are my two constructors, and then here's the first definition. Here's the second definition. I'm not sure what you mean pass in a type. Just trying to template technique reference counter. Reference counter. I'm like double checking all the things I have to have. They're all there. Pretty sure all there. I don't need a return value here because the constructor. Reference counter. It's not misspelled. Sublime's telling me it's not misspelled by putting a box around everything. I don't know what you want, sir. Template type name T. Error. Reference counter is not a class, type, namespace, or enumeration. I don't know. Am I missing something dumb? Am I a bad programmer? The answer is, of course, yes. But I don't know, man. It's not a class, namespace, or enumeration. It's right there. Maybe it's this friend class that screwed it up. Delete that. Now it's just complaining. Now you're just complaining. Oh, error private field is not used. I know that. Reference counter is a class. It's right there. Oh, I get it. Oh, I get it. Oh, I get it. I get it. It's a fucking... It is a template class, which means I have to do this number right here. T. That's all it is. It's not a class. It's a class template. So the compiler was right. It's a template of a class, not a class. Thank you, compiler. Thank you for letting me know that. I appreciate that. That was very nice of you to make that point. Use of class reference count. Oh, right here. And good. Okay. We're done with that junk. Unknown template name reference counter. What? Oh, that's because I have to include it. That's fine. Include reference counter.h. That, there we go. We both saw it at the same time. too few template yeah, okay. So now it's going to complain about the whole number of template arguments thing, which is fine. Type name S. Type name S. Or just S. Nope. And so now I get to generate, okay. I still have no guarantee that this will work. Vertex shader data and fragment shader data. I might come to the end of this and then C++ is like, nope, you can't do that. Sorry, them's against the rules. No type vertex, oh, that's right, I have to say data. Wonder if it was more clever to put the camera over the log. I mean, the actual errors are usually short. Oh, yeah. Damn it. The camera. Yeah. Let's split it half and half. I need to figure out how to put a box on my screen where the camera is, so I just don't put anything there. Sorry about that. I've been too lazy to figure that out. No type name vertex shader data. Now I know that exists. It's right here. In resource data. Oh, that's right, because I took it out of resource data. It's no longer in resource data. I took it out so that I could do stuff. Okay, now we're talking. Okay. Note. Instantiate. Yeah. Damn it. Remember access to incomplete type. Yeah. So I can't use this for declared vertex shader data. Oh, C++. You're killing me. You're really killing me here. So I want to keep this vertex shader data in my C++ class. In my C++ file, not in a header file. So that I can, so that I don't have to include my renderer in the header file, which I don't want to do. But if it's here, then I can't define the reference counter where I want to define the reference counter in the header file, because I would have to use a for declaration and then this type is incomplete because it will instantiate the type in the header file as it reasonably could. So like this is a C++ limitation though. See, the thing to understand here is that there's no essential limitation here. Okay? The compiler in a perfect world, in a language better than C++, would be able to just go find my struct definition over here in the CPP file and say, oh, I see you have it's a ref counted object. Okay, that's cool. I got it. I don't need this stupid, like, for declaration is a horrible thing because of C++. Well, really, it's C's fault. And C++ just inherits from C. It's C's fault. Translation units, right? It sees that and it's like, oh, I give up. I don't know where it is. All I have is a for declaration. In a better language, it would be able to just read through here and say, okay, here it is. Like, if we had modules, for example, you'd be able to do that. But we don't. We're stuck with C and C++. And so we have a stupid problem, and my reference counter is dumb. Now what? I made this amazing type-safe reference counter tool, and I can't use it. Um, gonna do this instead. I'll do this instead. All right. Super hack. Super hack. Probably not going to be happy about this. Struct resource. There. Done. Oops. Public reference counted object. Super cool. Problem solved, right? No problem. And then these guys can just be a resource. Think this should work? And then the resource can contain this data. A subclass of the resource can contain that data. I think that's reasonable. I think that's reasonable. So let's template. Let's templatize this on asset type T. And we'll go ahead and do this thing so that we have that information too. I think that'll be fine. So then over here, I'm gonna say no, not like that. Yeah, I mean, so I leave this like this. Good. And then I have to template this like this. Asset type, vertex shader, and fragment shader. Yeah. This will probably work. No viable conversion. From resource handle to something else. What? Generate resource handle. Vertex shader handle. Vertex shader handle. Vertex shader handle is a resource handle. Vertex shader, resource, vertex shader. Oh, it's because I have to resource handle like that, I think. Is that right? Resource handle. No, this is already done for me. What? What? I don't even get what this ... stuff is. Struggling with templates is not what I wanted to do tonight, FYI. Note, candidate constructor not viable. No conversion. From asset type 1? That's vertex shader. To... So this has vertex shader data right there. And this is resource... Oh. 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 Okay, I think I just have to... I think I just have to do this. Yeah. Okay, so we're back to the linker errors. So that was a bunch of template mess. Then the question is, can this generate resource handle function? Hopefully we can contain all of this template mess inside this resources class. And then this generate resource handle class can... No, because I still have to create the actual resource. No, this is fine. This is fine. Because I can create the actual resource. Okay. Say I create it, I'm going to create it right here in load asset. And when I do that, I can inherit this guy from resource, but create it using this guy, but it'll still all work because subclassing. It's probably fine. It's probably fine. As soon as I start doing all the template stuff, I lose everybody, I'm sure. Yeah, so then the idea is what goes in this generate resource handle. I just have to like pass into it. So I have to generate a resource handle, which is a reference counter, which needs an object. So it's not enough to give the ID anymore. I actually have it. I actually have to have an object that I pass into it. So that means what I said before is wrong, and I need to do this. Okay, so I need to load the asset first. Need to load the asset first, and then generate an object. So load asset. Load asset. Where's load asset? We'll return an object, some kind of resource. Maybe load asset should return the handle itself. Oh, man, I don't even know. Templates make things hard. Type safety makes things hard. So I think somebody asked me in a previous stream, like, why not Haskell or something? What was the question? Why not, use Haskell and monads and abstract type theories, all this stuff. And this is why, basically. Like, it makes it a lot more difficult to do this exact thing. You spend a lot of time trying to get your types right, which is what I'm doing right now. And not as much time actually coding, like actually solving the problem that I have. I've not spent, like the last hour or something has not been spent solving my essential problem. It's all been spent trying to get my types right. So this is like a sign that maybe I should back off on the types and just have like resource handle and that's it, and do runtime checking. Runtime checking is not so bad, honestly. Like, you feel really smart when you get these types right. But maybe I can just do some simple runtime checks and they'll be slower. How much slower will they be, honestly? Like, you don't do these checks so often and you can work around the checks. Like, we had plenty of ways to make fast programs before templates existed, right? Yeah, that's part of programming, like deciding when to make this trade-off. And I think I'm gonna go the other way and back off on the whole templateness. I did too much template. Too much template. So, yeah. Too much template. So what does that mean? What does that mean? How do I undo all this template? So I got to think of like a new strategy now for doing these resources. So let's start here. Let's start here. Let's start like that. And probably this. We can move this back into the header, into the C++ file where it belongs, honestly. Check out master. No, I have other I have other things. I don't want to just blow all of this away. Like, I still want my reference counter. I just don't want it to be templated. I'm not going to write it from scratch here. Ref counted object. Ref counted object. All right. So now I can do ref counted object here. Or better yet, my shader handle, I don't need this template parameter. Okay. Resource handle. I don't need this template parameter either. So things are becoming simpler. Resource handle to a vertex shader. I can deal with that. I'll do the runtime checking. No big deal. Get rid of this resource. I may actually want to still have that at some point, but I'm gonna get rid of it for now. Ref. So this is gonna turn into ref counted object, reference counted object, and yeah. Let's see how that works. Back to this redefinition of reference counter. Oh yeah, there we go. Getting rid of the templates. Unknown type name T. What? Here we go. Reference counted object. Reference counted object. Too many template arguments. Can fix that. Okay. Can move these back down here. Use of undeclared identifier resource. Oh, yeah, we can turn all this back. All right. All right, we're back to the linker errors. All right, good. So we generate a resource handle. We're still gonna need to pass an object into that though. So actually, I think we are gonna need these guys, these two lines right here to be further down. We need to generate the handle after there's an object available to make a ref count to. And load asset will have to be the thing that that does that. So yeah, I think I want to bring back this struct asset, or I'm gonna do resource. Because it's a resources and resources. So, and this is going to be my ref counted object here. Public ref counted object. And it's going to have an asset type at the very least. Defaulted to asset type invalid. So this is what I'm going to do my runtime checking with. I'm just going to check it against this type right here. So then these two guys are going to inherit from resource. So, like, if you watch, like, Handmade Hero, and don't get, like, Casey is an amazing programmer. What I'm about to say does not discredit him at all. But a lot of, it's not just Casey, a lot of programmers, especially in the game industry, will tell you never use object hierarchies. You know, like, object-oriented programming, bad. C is good, you know? And I don't know if I buy that completely, because I just made an object hierarchy here, right? Like, this guy inherits that guy, and that guy inherits that guy. And that's useful. Like, I haven't written any virtual functions yet, and I probably will, but the virtual functions are only going to be at one level. I'll define them here. Virtual such and such. Okay. And then I'll override them here. Override here. And that's it. Like, I'm limiting my application of virtuals to that function. Because it's the right tool for the job, honestly. Like, there's a resource, and there are a lot of different types of resources. But there's only one level deep. You're only a vertex shader resource, or fragment shader resource, or model resource, or texture resource, right? You're never like a texture resource and then something else that, like a normal texture resource. No. Once you're going that many levels deep in your class hierarchy, something's wrong. You got to scale back. But I have no problem doing just a single level, right? You know, a single level right here. I say single level when it, you know, there are really like 2 levels or 3 levels. But resource has a bunch of child classes and that's it. Like, I don't think there's anything wrong with that. Especially computers are so fast these days, they'll just burn through the virtuals and that's no problem. So don't judge me for my use of so we can put resource ID up here too. We don't need that there. Everything's gonna have a resource ID, right? So there's that. So that means that this guy will need a resource. Good. Which load asset will return. So load asset returns the resource, and then you generate a resource handle out of it. So let's see. Resource, and then pass that right into there. So in the implementation, let's go ahead and write the implementation of generate resource handle right now. This should be fine. This is templated, which usually means I was going to point that out and got distracted. Good. Usually, the fact that something is templated means you have to declare it in the header, but I'm going to declare it in the source file, and I bet you it will work. Because the source file is the only place I'm going to use it. Because it's private. Little trick there. Pretty sure that's true. Pretty sure that's true. So return resource handle T, give it the resource. Actually, that's it. That's all I should have to do, I think. Well, maybe not. Use undeclared identifier. What? Handle. Oh, I can no longer do this, I think. Yeah. It's a bad design anyway. I now realize. So load asset no longer takes a resource ID. Oh wait, no, this is a problem, isn't it? I need to know a resource ID. So yeah, I need that there. So right. So I need to generate a resource ID first. This is weird. This is weird because I'm loading a fragment shader or a vertex shader or something like that, and then, but like if you call this function and there's already an existing fragment or vertex shader, you don't want to load it again. You just want to get a handle to the thing that already exists. I'm not handling that yet. Okay, I'm not dealing with that yet. I'm just going to generate a new ID, a new resource ID every time. So this is a bug. I'm writing a bug right here, but I'm cognizant of the fact that I'm writing a bug. I'm going to go back and fix it later. You got to do that because it's just stuff is too complex. You can't like do every feature at once, you know. Return type. Yeah, that's true. Okay. Resource, and then we got to actually return a resource. Oh, that means we have to have a list of resources. All right, we can do that. Resources, and actually this is going to be a list of pointers to resource, because we can't allocate the actual resource in this list because we're using because we have an object hierarchy here, and each resource might be a different size. So we're just going to allocate the resources one by one. It should be fine. So we're going to do that now. Resources dot push back. So now, asset type. So now is where we have to use the asset type. Okay, so great. Another function. Create resource at asset type. This should create the correct resource that we need. Okay. It's basically just going to be a big switch statement, a switch on the asset type. It could be templated. If I were doing it the C++17 way, it would be a template function that's templated on the asset type. But again, we're not worrying about that. We're not worrying about that. Actually, no, I'm going to do it that way. Actually, I like that. I changed my mind. Templated on the asset type. Template, asset type T. Great. Perfect. Wait, not great. Asset. That has to be known at compile time, and we don't know at compile time, so I can't do that, so never mind. Yeah, we'll just do a big switch case. Normally, you would know this at compile time. Normally in C++14 or C++17 code, you would know the type at compile time because everything is a big-ass template. And then this would be a templated function that you have specializations on the asset type, and then it returns the proper thing. But we're not doing it that way because, you know, I don't want to do all those templates. So we're just going to create the resource, push it onto this list of resources, and then we have our resource there. Great. Return resources dot back. Yep. What? Oh. Great. No matching conversion for functional style cast from resource start to resource handle. What? Resource handle is a reference counter. It returns a resource handle, and a resource is a reference counted object, Wait, what's the C++ 17 way? I think I just explained that. To like use templates and specialized templates, which is a compile time equivalent of a switch statement. If I didn't answer the question, let me know. No matching conversion for functional style catch. That's weird. This is not a functional style cast. This is a constructor. Oh, maybe that's why it thinks it doesn't realize. Okay. I just have to write a constructor here. Okay. Yeah. Resource handle. Takes a resource. Now there's a constructor. Now you're not going to complain, right? Oh. There. Don't need this anymore because the resource ID is already contained in the resource, so that should be fine. Come on. What the hell is going on? No matching constructor for initialization of... Oh, because there's got to be a default constructor. Okay, so basically I have to rewrite all of the constructors now. Fine. I'll rewrite all of my constructors. Okay, here we go. So let's... These are super simple functions to give definitions for, so let's go ahead and do that real quick. Resource handle T, and done. There's that one. And then this one has to be given a resource, and we're just gonna call the parent constructor, which is reference counter, on the resource we were given. Done. Okay. Out of line constructor for resource handle cannot have template argument. Oh, that's right. Yeah, because template, damn, template class is a template. And this guy is actually going to be used outside of this header file. So I have to put it down here. Resource handle, that should work though. Why isn't that, cannot have, oh, that's right. You just gotta, this syntax is weird. This syntax is weird. I don't know. You put the T here, but you don't put it there. I don't know. I don't know what's going on with that. So generate ID is a stupid function. I'm not going to bother implementing it. Generate resource handle is the questionable one, but now that looks like it's done. Create resource is dumb. It's just a switch. Okay, so good. So good. Good. So we need, though, we're not quite done here because we want to, So this resource handle is templated on the asset type. And I want to make sure that when I dereference the handle to get the resource, that it does that checking. You know, I'm not going to do that right now. I don't think. Because I don't actually have the object that I want to return. I don't even know how you would return the object. Maybe you don't. Yeah, you don't. You never actually return the raw data, do you? Because like you're like it's just like a handle. You get it back from the resources manager, and then you just have that handle, and you pass it into whatever other system, and then that system gets the actual data. So this should be fine. I don't need an accessor here that says like get the actual resource. Should be fine. So, but what I do need is, okay, I finally have these stupid handles. Okay, vertex shader handle and fragment shader handle. Good. So over here in shaders, I push all these handles back, And then when shaders gets destroyed, I destroy them. So what that should do is, now that I have all this reference counting stuff done, it should up the reference count when I push them back here, and it should decrease the reference count when I clear them. And that should decrease the reference count back to 0. And so when I destroy resources, right here, I destroy all the resources. I need to go through, and for one, like, I need to undo this create resource. I need to, whatever, I need to delete that. The actual resource pointers that I made, I need to delete. And then I need to call the opposite of load vertex shader. I need to call delete vertex shader on everything. And then if I ever have some ref counts that are not 0, then I'm in trouble at that point. So let's do that. Let's do that. All right, let's go ahead and write these functions real quick because they're so easy to write. We'll just get them out of the way. So resource ID, we're part of the resources class. We generate an ID. Okay, what's that mean? I return the next ID. Well, let's do this. Resource ID result equals the next ID, and then next ID is equal to create it. You have to do a lot of casting here because this is the thing I was talking about, how it doesn't coerce to integers even though I want it to convert. So you have to convert it to an integer, then add 1 to it, then convert it back to a resource ID, and then you return the results. So that's an easy function to write. Did that work? Yes. Okay. And then the other one was create resource. So that returns a resources, and then it is a create resource, and it has an asset type. And it's a switch statement on the type. So if you give me asset type invalid, I will give you null pointer. Also, I will assert. You should never try to create an invalid resource. What am I working on? At what stage will you consider it done? Async base for an engine? Yeah, an async base, like an yeah. I'm just doing this like in my spare time for fun. I've never done it before, so there's no like thing that I need it for. There's no bar for considering it complete. Unlike, for example, the file format library that has a bar for if I ever want to release that, then like there's a bar for how complete it has to be. But I'm not going to release that anytime soon either. I'm just doing it for fun, really. There's no like when I'm done with this, I'm going to get back to actually rendering stuff, which might be good. And that'll be interesting. I'm just playing around, really. There's no metric here. If I were doing it for an actual thing, I'd probably not make my own engine, honestly. Kind of foolhardy to make your own engine. So let's see here. Return new. Oh no, I don't want to use new. No, I can use new. I can use placement new. It'll look like that. Does this call the constructor actually? Valak. It does. Why did I do that? That sounds like a bad idea. No, it's fine. It's just like new. It calls the constructor. That's fine. Okay, anyway. So this thing calls the constructor, so that's fine. BRDF. Yeah. See, I want to. Yeah. So, funny story. The whole reason I'm writing a renderer in the first place is because I wanted to get some practice in doing BRDFs. And like, so I was writing the renderer and I got pretty far. Do I have an example? Yeah, here's my renderer. Ta-da! Render, done. So when I clicked right there, it generated all the light maps, right? So the idea was, okay, I'm gonna write a renderer because I want to get better with BRDF. And BDRF? Isn't it BDRF? Bidirectional something function? Bidirectional reflection function? I think it's BDRF. And so I was like, well, the first thing I need to do is have like an environment to do BDRFs in. And I've never done a light mapper before, so I'm going to write a light mapper. So now I have the light mapper. And then I was like, well, now I need to get my light mapper into my, like, when I press Control G. Come on. Did I do that right? Maybe not. Okay, well, there's some button here. I forget which like, this is the editor. There's some button that will bring you into the actual level. But I need to be able to like write out the level file, thereby baking all of the, you know, all of the lights that I calculated here. Bidirectional reflectance distribution. Oh, bidirectional. Oh, so it's not B the D in directional. It's the B. Got it. Thanks. Thanks for clearing that up. I always forget. Anyway. Yeah, like I wrote the light mapper and I was like, well, I need a file format to load all these light maps into my level. And so I wrote the file format library and then I went back and I was like, well, like I'm not really doing this engine right unless I've just been yak shaving for months. Months and months of yak shaving, which is fine because I'm just learning stuff. So it's just good practice and all that. Months and months of yak shaving. It's been fun. Actually, this is a good opportunity for me to use my file format library, I think, because I really don't like this size thing right here. So I'm going to do that. Watch this. Watch this. No, I can't call it resources because that's the name of my class. So I'll call it resource utils. I don't know. So in this case, invalid is 0. And then fragment shader. And then vertex shader. And then fragment shader. And actually I can just leave this off, I think. And we'll make that, yep, a bigger number. Save that, compile. All right. And then I can, wait, asset type is the name. Asset type. Then I can delete this asset type. Yeah. And include the reflection file I just generated, which I think is called, what is it called? Generated formats.h. Generated formats.h. So now I should have asset type, everywhere I refer to asset type, I should be able to refer to resource utils asset type instead. Oh, come on. Oh, not in the templates. Not in the templates. Or yes, in the templates. Speaking of BRDF, does anyone know where the 4 is derived from in the denominator of the microfacet equation? I have no idea. I've also seen pi. Oh, 4 pi? Is that the reflection system you built a few months ago? Yes, it is. I'm now using the reflection system I wrote a few months ago. If it's 4 pi, that's probably... I'm going to make a stab at understanding this, but I probably won't. Microfacet equation. I've been here before, apparently. Some random ass blog. Oh yeah, the 4. Nope, I have no idea what that 4 is. Can't help you there. These are all models, though, so I wouldn't read too much into the models. Like, it's some dude just came up with an equation that was like, this looks good, you know. Looks good. It fits the data when I have a 4 here. Where'd the 4 go? It fits the data when I put a 4 there, so I put a 4. There might be a physical basis for that 4. I'm, you know, or there might not be. I don't know. All right. So include generated formats. So let's open that generated. So I just told my file format system to write me an enum. The idea being that, where did I even put it though? Oh wait, it's gonna be over here. The idea being that it can also write the size of the enum. And then you like the number of elements and the max element and all this stuff. And then I'll have to use that gross size stuff. I probably shouldn't have tried to make use of it right now while we're in the middle of something else, but I was feeling adventurous. And I didn't even write it. What? What's going on? Or what's the target name? I don't even remember. Generate reflection. Make generate reflection. Let's see if I can force it to run. Nope, that's not the target name either. Compile formats. Compile formats. It already did it, I guess. Okay, maybe we shouldn't do this just now. Well, I wanted to impress you guys, but it's not very impressive. We'll do this later. I'll just go back to, yeah. Let's just do one thing at a time. I'll do that refactoring later. All right, where were we? Yeah, see, this is why. This is why I was inclined to do that at the, because now I have to type this very gross code. Gross. 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 Yeah. So later on, I'll just go and move that into my reflection system, which will hopefully generate a, not reflection system, oh my god, my file format system, which will generate an enum that has only invalid vertex shader and fragment shader in it. And I will have to do this size. Because if I don't have the size, then the compiler complains. It says enumeration value size not handled in switch. Well, you have a size thing in your enum class, but you didn't handle it in the switch. So what if someone passes size to you? You should handle it. I'm like, well, size is a gross thing. So whatever. All right. Good. So good. So we're compiling now. And we're linking. What's the final step here? The final solution. Is right here. Free M data. No, we don't want to do that yet. So before we actually free the data, we have to, what is the data? 4 int k equals 0. Should probably do size tk. And we look data dot vertex shaders dot size. So we're gonna iterate every vertex shader and then every fragment shader. To do what? So we just have a, no, we have this is a list of resources. So this is a list of resources. So the very last thing we're gonna do is free it. Wait, no, what am I doing? I wanna walk the resources. I just wanna walk the resources. All resources, not just vertex shaders or just fragment shaders or anything. Just gonna walk all resources. All right. So yeah, the last thing we're gonna do is free the resource. And this is dangerous. This is dangerous because I really want to call the destructor on it. So I should do that, which means it has to have a virtual destructor. For anybody not familiar with the whole virtual destructor problem, if I do this, okay, that will invoke the destructor resource, and resource has a default constructor, like an implicit destructor, which it will run, and it will do nothing because there's nothing here to do. But it won't invoke the destructor of any child classes, like this one or this one. That's no good. So I have to force there to be a destructor that is virtual. All right. So using a little more C++ than some popular people with popular Twitch channels would do. But that means that anybody can now go add a virtual destructor. I anticipate probably to never have to use that virtual destructor, but it's there now. It's there just in case I have to use it. Just in case somebody goes here and adds a destructor here, fragment shader data, it will work. So I'm not gonna add a destructor. I don't think I need one. But in case I do, actually I don't need that either. Yeah, because vfree will call the destructor. I had to do that. Valec.h. So vfree does call the destructor right here. And it will use magic of virtual function table to call the correct constructor. All right. So how are we doing so far? Equals default. Can I do that? Can I default a virtual function? Come on, baby. Default a virtual function. Good. Then I don't have to write it. I just instruct the compiler to use the default. So, but before I free it, before I free the resource, as in free its memory, I want to unload the resource, unload asset, and I should rename asset to resource. Just occurred to me. Except here. The dangers of global replace. Good. Hold on, let's make sure that didn't screw up anything before I go. Asset utils. Okay. Resource, good. Unload resource is going to be a function. Unload resource that takes a resource as a parameter to unload. And yep. There we go. All right, it takes a resource to unload. It will unload it. Good. Unload resource. Resources K. So we're gonna have to do some kind of runtime dispatch on this resource because you have to unload different types of resources differently, but that's fine. That should be fine. Since we're on virtual constructors, would it make sense to make the resource class abstract/pure virtual? I have never, you can, like I could do this and now it's an abstract class, but I've never really gotten anything out of that. And I have, like, I've never gotten, well, actually, I can't do this because this is the destructor. But, like, I've never gotten any benefit from making it pure virtual. It's like it's like an abstraction, a pure virtual, like a thing that can never be instantiated. It's like forcing you never to be able to instantiate the thing, which is great, except that crashes. Called a pure virtual function call, which is the worst kind of crash because it doesn't actually crash. It, like on Windows, it pops up a window that says you called a pure virtual function call, and then it doesn't go to your crash handler, and then it's like, ugh, it's the worst. And I would rather it like not do that because these crashes are always like, oh, you tried to call a virtual function within the constructor. Well, you shouldn't, like, I don't know. That's the only cause of like a pure virtual function call error. You tried to call a function from the constructor and like, I don't know. It's problems and you don't really get much out of it in terms of type safety. So I don't know. I don't usually do it. That's arguable. So I would be willing to listen to arguments on either side of that. Anyway, let's go write this load. Load resources called now. I just changed the name. Resources unload resource, and we get a resource handle. So we have to do another switch on the resource type. So case resource type invalid. That's an assert and a return. Same thing for size. I could write default here, but then if I write default, then I could write default and get rid of both of these, and then it wouldn't be so gross. But then when I add something to this, I won't get that nice compiler assert, or compiler like here. It's telling me, hey, this thing that you just added is not handled in the switch. But notice it told me that for this one, but it didn't tell me that for the one that I added the default, right? Like it didn't tell me for this one. So if I add it here, case resource type now the compiler says nothing, right? So it doesn't say anything for this one. I want it to. I want it to tell me when I've forgotten to add something. So FYI, there's a little sidetrack there. I have a 3D mesh abstract class, which is an abstract class that has a triangulate pure virtual function, and I derive different procedurally generated mesh classes from it to generate the geometry, and the base class holds all the buffers and calculates the normal class, the normals and stuff. While I am skeptical of the fact that a 3D mesh needed to have child classes. That seems like seems suspicious. But regardless of that, oops, class 3D mesh. So you're saying you have a triangulate, which is a pure function, pure virtual. You derived, and then you have class whatever other mesh. This should say virtual, I guess. And you have an actual triangulate. And then you have an actual, like, stuff specific to your whatever other mesh. So, yeah, sure, I agree. But couldn't you just do this? You know? You just do that. And then you're more in control of the error that you get when things go wrong. Because this is going to happen when someone, you know, 3D or even down here, whatever other mesh, never do this, triangulate. This is the way that these errors happen, right? You call that virtual method from the constructor. And it's going to go here instead of here, and then you're just going to immediately hit that assert, and then you'll be good. So this way you can just implement a sphere, cone, or torus by deriving that class. Implementing triangulate function to calculate. Oh, I see. So it's not really a 3D mesh class. It's like a 3D shape class. And you have a triangulate function that returns a mesh. So like this is, I don't know if you care to have my opinion on this, but I'm still gonna give it to you. This is the way that you should 3D mesh shape, public shape. And then, so you have a, so this is like a sphere, and then you triangulate the sphere to get a 3D mesh, right? Or even generate mesh, right? Because this way, like a sphere is not a 3D mesh, right? A sphere is just it's a shape. It's just some kind of shape. You can generate a mesh out of it. You know, you triangulate it. Maybe I don't understand like your problem domain, so I might be like talking out of my ass here. But it sounds like when you say triangulate, you mean generate a mesh for that shape, and then so you really should have like a separate 3D, because a 3D mesh, like, okay, so you have, if you have this. If you have this, like, what are the properties of mesh that a sphere can have that any other mesh can't have? You know, like, I don't know. I don't feel like 3D mesh is the sort of class that should ever be just a 3D mesh that should ever be subclassed. By its very nature, a 3D mesh can be anything. You have a mesh of anything, right? I have a mesh of a sphere. I can warp that sphere, and now I have a cube. Or vice versa, and then like your organization here is broken down. Does that make any sense? Like you remove some verts from the sphere, and then, or not some verts, some triangles from the sphere, and then like press the holes together, and now you have a torus. You just hit a way non-isotropic calculation, or what's the term? Is that the term? Isotropic? Yeah, like you get it. You have to punch a hole in it so it's not like homotopic. I think it's homotopic. You did a very unhomotopic operation. But, I don't know. I never took topology, so I don't know what I'm talking about. But you get what I mean. Like, you took one mesh and you turned it into another, and it's now no longer a sphere at all. So that's, yeah. So, anyway. So we gotta destroy this thing. We gotta unload a resource. Vertex shader. Let's do it. How do we unload a vertex shader? Well, we call unload vertex shader. What do we pass into unload vertex shader? I don't even know. Let's just pass the resource ID. Resource resource ID. We'll do that. Same thing for fragment shader. See you, cats. Yeah, I'm gonna wind this up myself pretty soon. It's getting past my bedtime. Ooh, it is past my bedtime. Unload fragment shader. Oh, yep. I'm gonna need this instance, so that's good. I'll save that. Oh, that's weird. Oh, yeah, that is weird. Well, we didn't get as far as I wanted to because I had to struggle with C++, but it looks like we're... so, this problem makes me not want to continue tonight. Because, apparently in order to unload this resource, we need to call into the renderer. So we need a pointer to the renderer, which means that we need to pass a pointer to the renderer into unload fragment shader, which means we need to pass a pointer into... So here's unload fragment shader. We need to pass a pointer to the renderer into unload resource, which means we need to pass a pointer to the renderer into destroy, and I don't know how I feel about that. Doesn't seem right at first blush that you need a pointer to the renderer in order to destroy the resources. Yeah, it's because at the point that we destroy resources, anything that is like at the point that we destroy the renderer, we should starting over. At the point that we destroy the resources class, all resources should already be freed. Right? So I really need another function here that says clear unreferenced resources. And then this loop goes there. Void resources, and then clear unreferenced resources. Now this thing can take an instance. Instance. No problem. I have no problem with that. It's totally reasonable that that you need a pointer to the renderer in order to clear things. So this loop goes here, but it doesn't free anything, but it does free when you destroy. All right. Compile that. Oh, and so now we need to pass all this through. So unload resource. See, this is still weird because load resource apparently didn't need an... Yeah, no, that makes sense. Load resource doesn't need a pointer to the renderer because it does everything deferred. One last question. What window library are you using for my renderer? SDL. It's SDL. I would like to rewrite it so it doesn't use SDL because sometime in the far, far future, I'm considering possibly distributing this thing and making it like a general purpose thing people can use for like a low level renderer. In which case I gotta get it off SDL. But for now it's just SDL because that's simple. So unload resource takes the renderer, and then the renderer we can pass into. I'm still not terribly thrilled about this design because unload vertex shader because my shaders need a renderer to free themselves, but other resources don't. So I have to pass this renderer in here regardless of what resource I'm freeing, even though like a physics resource, for example, or audio resource, like so for the like this is not going to scale because then for physics I'll need so I'll need to pass in the whatever physics engine I'm using to unload the physics resource. And then I'll need to pass in what audio engine I'm using to unload the audio resource. And so I'll need to pass in like a bunch of stuff here. GLFW is also good. FreeGlut is not as good as GLFW, and you did well to switch. Yeah. I used GLFW for a long time as well. There's nothing wrong with it. I don't know. I don't even remember why I switched to SDL. Yeah, whatever works best for you, honestly. I don't think SDL has any distinctive. It may be like there's somewhat better support for some things in SDL, I guess. But there's nothing wrong with GLFW, so. All right. Great. So let's write these unload functions. Unload vertex shader. So what I gotta do now is loop through all of my fragment shaders, or vertex shaders. Vertex. And free the ones that match this resource ID. So where was it? Oh, damn it. Okay, yeah. This is definitely something I don't want to do tonight. I made a little bit of a miscalculation here. Because this should be a T array. Should look like that, basically. Yeah, because recall, yeah, I'm just gonna have to deal with this. Recall that each shader has a number of profiles. So this is like profile IDs. Each profile is individually sent to the renderer, so this is gonna break everything basically. Which is no fun. So now I have to loop through a list of profile IDs and yeah. All right, well, then I'm gonna call it there because I'm tired, I'm sleepy. Yeah, too bad. I think this is the first time we actually haven't gotten something concrete done by the end of the night, which is disappointing, but it's just too much work. It's just too big of a task. So, well, that's too bad. Some good progress was made, though. Satisfied with the progress that was made, even though I had this big, like, detour through all the template crap. It'll probably be better now that we simplified it. Yeah. Yeah, that's like when you get tireder, like the level of complexity that you're willing to withstand before you just want to go to bed just goes down and down. Like you get more tired, and the level of complexity you can withstand goes down until and the level of complexity you're dealing with just goes like this, right? And then and then at some point, like you realize you had some problem that you didn't know you had before, and your complexity level is going down, and then you just drop up above it, and then you're like, oh, that's it. I'm done. Going to bed now. Thank you, everybody, for coming. Had a lot of fun this time, like I always do. A lot of good questions. Yeah. What are we going to do next time? What are we doing next time? We'll see if I can make some progress on this guy and get to the actual rendering stage of it. I would like that. I would like us to get to the actual rendering stage. So I'm gonna do as much progress on the asynchronous resource loading. Hopefully I can get that all out of the way over the next week, and then we can actually do rendering stuff next week. That is my hope, but I may not be to that point yet. Might be close. Tough to know. This is all very experimental for me. As we saw today, I was making a lot of missteps. So there's still a lot of things that I don't think I did too great, but you know, we'll get it. We'll get it over the coming weeks. I really want to get back to where we're actually rendering stuff, because then I don't know, it's more interesting. You can see stuff. You know, it's not just looking at code, but it's like flipping between code and an actual game that's being rendered. You know, like I was showing before. Well, it's closed now. So that's my goal for next week, to get closer to something that's actually rendered, so that we can have something to look at. At that point, I'll probably do coding for this thing only on stream, and then off stream work on the compiler some more, and get that to the point where we're seeing something too, so that we can switch between the website and the renderer, and we can do whichever one is more fun that week, something like that. So that's my current thought. Although, you know, I'm open to suggestions. If anybody has an interesting topic like bare matrices that they think would make a good stream. This is more educational than actual rendering. Good. Good, yeah. If anyone has a good topic that they're interested in, we can do that too. I don't know. If it interests me, I'm not I'm not gonna promise to take on any random topic. But suggest topics if I like them. Maybe we'll make a detour to work on something like that. So again, thank you everybody for coming. I hope you had fun. Hope you learned a lot. Peace Layer 89 certainly did, it appears. I always learn a lot when I do the streams and have fun. So yeah, we'll see you next week. Hopefully my